Hi guys, today we're going to be looking at graphing absolute value equations. Remember, they're V-shaped. They mirror each other. They have a vertex, the highest or lowest point. So like this point here at 0, 0 is the vertex. Now, this is the parent function y equals absolute value of x. On the next page, we're going to be looking at different shifts. So it could be horizontal, vertical, or both. And these are the graphing rules. This is the general equation for an absolute value. HK is the vertex. Notice it's minus h. When it's minus, it moves the graph to the right. So if I had absolute value of x minus 2, that would move that 2 units to the right. So it looks something like this. If it was plus, and move it to the left 2 units. Then the number on the outside k shifts the graph up or down. So if I had plus 2, it shifted up. If we had minus 2, that would shift that down 2 units. And then this negative in front, for this one, reflects the graph, making it look like an upside down V. So a reflection would look like this. And then y equals a times absolute value of x. A is the slope of the absolute value. If there is no number in front of the absolute value, then the slope is 1. And all these today are going to have a slope of 1. Okay, next page. Describing transformations. Below are the graphs of y equals absolute value of x and y equals absolute value of x minus 2. How are the graphs related? Well, look at how the vertex changes. The vertex is this point. It went down 2 units. That's how you would describe the transformation. Next page, graphing a vertical translation. Y equals absolute value of x plus 3. Well, you got to ask yourself, what does the plus 3 do? The plus 3 shifts the graph up 3 units. So from 0, 0, always start at 0, 0. You're going to go up 3. Then the slope of an absolute value is up 1 over 1. You're going to do that on both sides, and then draw a V. That's how you graph an absolute value. Okay, graphing a horizontal translation. For positive numbers h, y equals absolute value of h, or x plus h, translates the graph h units to the left. If it's minus h, it translates it to the right. So this one is going to move it to the left 3 units. So you go to the left 3 units, and then slopes 1. And you draw a V. All right, the next one, x minus 3, shifts the graph to the right 3 units. So from 0, 0, go to the right 3 units, which would be right there. You draw a V, and we're done. Okay, these next ones have a horizontal and a vertical translation. So you got to remember, this plus 2 moves it to the left 2, and then the minus 3 moves it down 3. So you're going to be at negative 2, negative 3. That's the first point you're going to plot. So left 2, down 3. would be right there. You plot your point, then the slope of 1 on each side. Over here, first off, notice it is negative there. So that means it's going to be a reflection. Instead of being up like this, it's going to be down. Remember that minus 5 moves it to the right 5 and up 4. So you're going to plot a point at 5, 4. And then remember, the negative makes it go down. So you're going to draw your V going down. It's got to look like a mountain, not a V. So that's how you graph those. On the next page, writing an equation for each translation of y equals absolute value of x. If I want to translate it 2 units up, if this is my parent function, to translate it up, you just have to write y equals absolute value of x plus 2. If I want to move it 3 units to the left, remember, addition inside the absolute value moves it to the left. So that would be absolute value of x plus 3. If you want to move it to the right, you're going to write absolute value of x. A minus sign would move it to the right 4 units. Then 7 units down, you put that minus 7 on the outside of the absolute value. And then last one, 5 units to the left. Remember, if you want to go to the left, you put plus inside the absolute value. And that's how you write the transformation. Okay, this is something different. An absolute value function is an example of a piecewise function. A piecewise function is a function that has different rules for different parts of its domain. For example, when x is greater than or equal to 0, the absolute value of x equals x. When x is less than 0, the absolute value of x equals negative x. Another example of a piecewise function is a step function. A step function is a function that pairs each number in an interval with a single value. The graph of a step function can look like the steps of a staircase. So this is an example of the step function. There's intervals. These are your intervals. And notice the last ordered pair is an open circle, because it doesn't include that number. If it's an open circle, it doesn't include that number. On the next page, we're going to look at an example of a step function, how to graph it. Okay, a school will charter buses so that the student body can attend a football game. Each bus holds a maximum of 60 students. Make a graph that models the relationship between the number of students X that go to the game by bus and the number of buses that are needed. Okay, so if you make an interval, when you have 0 students, you don't need any buses. 1 to how many students would give us 1 bus? We can hold 60. So 1 to 60 would be 1 bus. So this is number of buses. Number of students here. Okay, then the next interval from 60 to 120, you would need 2 buses. For 3 buses, that would be 120 to 180. Then from 180 to 240, that would be 4 buses, and we're going to stop there. So we're going to put number of buses for the y-axis. So we'll go 1, 2, 3, 4. And then number of students for the x-axis. So we'll go up by 60. And don't forget 0. So when you have 0 students, you need 0 buses. 1 bus would be from 0 to 60 technically. It's gotta look like a step. And then we close the circle at 60. It includes 60. Then, for 2 buses, 60 to 120. And notice I have an open circle, because once I reach 60 students, really, this is talking about from 61 to 120, technically. Then, for 3, I've already counted 120 once, so that's why I put an open circle. And then the interval is going to close at 180 students, so I close the circle. Again, we've already have a closed circle at 180, so for the next one, for 4 buses, the interval's from 180 to 240, we close the circle. This is a step function. This is how you make a step graph. And that's it, guys.